So the individual who has a telephone number 001, 0001, or whatever, he would be first, and so on and so forth, on down the line. Then we've put our sampling frame together. We number them from least to greatest, or alphabetical, or however you get your data, and we number them. And then we want to randomly pick numbers. When I think of randomly picking numbers, it brings back times when I would play bingo with my grandmother, and I would crank the wheel, and the number balls would kind of flip, and out would pop a number, and I would look at it. Okay, this is about as random as it comes. Yeah, but now we use computers to generate random numbers, and they will generate random number tables for us, but somebody had to program it and tell it what to do. There's a mathematical formula that gives you a random number, so it's really not random if someone designed it. Okay, it's proposed to act random, but whatever. Okay, so just listen, don't get confused, just listen. So however you use it, and most people are now using random number generators on the computer. Excel will do it. I think it's equals randgen, or equals rand, R-A-N-D, open parentheses, will generate random numbers for you from a list. But they use these numbers, and so, okay, so let's just say the random number 587,221 comes up, so they would go to the 527,221st telephone number, and they would call this number and ask, what do you think about Obama? And they would repeat this randomly, random number generating, go to that phone number, call. Sometimes you won't get an answer. Sometimes it's no longer working. Sometimes you get somebody, they hang up on you, and sometimes you get them and they answer. And you do this again and again and again and again and again until you get enough in your sample that you can make good decisions. And we said enough in your sample represents 30. 30 people in your sample represents enough. Okay? Now, that is the best way to do a survey, and you get the most true results if you can put everybody there. Now, we would say there's a bias towards young people there because young people generally don't have home telephone numbers. There's a bias towards homeless people. Homeless people don't generally have telephone numbers. And what does bias mean, spelled B-I-A-S? This means consistently low or high. Okay? We would say there's a bias, consistently low or high. Now, which means we don't have the youth represented, or we don't have the homeless represented, so we're going to be consistently low or high depending on what the youth's opinion of Obama is. And this was evident in the Jesse Ventura gubernatorial race in Minnesota. Jesse, the body, Ventura, who became Jesse, the mind, the senator, had a heavy youth following in Minnesota. And he was highly represented, but the polls did not have him anywhere as a front runner because he didn't have a good way of getting at everyone. Okay, there's another way to do a simple random sample, and if, for instance, you could get all the Social Security numbers and randomly generate a Social Security number and contact that person, but that's very hard. And all of these things are very, very expensive. But this is one sampling method, and you'll see that described on page 253. Okay. There's another issue with sampling, and it's called sampling with replacement or without replacement. Okay? If you're sampling without replacement, it means that when I get selected, I am no longer able to be asked again. Okay? So if my phone rings and I don't answer or I answer, it will never ring again from those same people if they're sampling without replacement. Meaning, they don't replace my number ball back into the bin to be selected again. In huge survey samples like that, it doesn't really matter if you're sampling with replacement or without replacement, because the probability of being selected is so low that it's probably not going to happen. Now in bingo, where there are 42 balls or 54 balls that are being cranked, they sample without replacement, meaning when they select the ball, they keep it out. And that way, they won't call that number again. It won't get called again. Okay? And so this is sampling without replacement. And so sometimes we make this distinction. Now, sometimes you'll see random number tables, and your book will tell you that you can use a random number table to be able to find a random number to do a simple random sample. Those are very archaic, out of date, and generally don't work for what we're looking for. They do work, but they're very, very cumbersome and hard to use, and we won't use them in this class. So, the problem, the good, let me say some goods. The good is that it's the best sampling method. Okay, the best sampling method. And the bad is it's expensive. And it's time consuming. These are the two major drawbacks. Even if we were going to limit it to a city like Dallas, if I were going to take everybody's telephone number in Dallas, or I would just generate numbers with my computer in the 972 and 214 area codes, if I were going to have to measure the weight, let's say I'm doing a study on weight, and I have to physically go to measure the weight of someone. If I do a simple random sample, if this is the Metroplex, with this being 360, and Fort Worth here, and Dallas here, if my first subject was here who answered the phone, and my next subject was here, this is a 2-hour drive. And I have to go to him, and then I come over to her, and then back to him, and back to her. And you can see, as I'm doing this, you can just count up how long that's going to take. That's going to take forever. I mean, a very, very long time to sample people. So there has to be a better way, and there is. Okay? Another sampling method that we have is called stratified sampling. Stratified sampling. Stratified sampling. Now, stratified sampling has a root word, strata. Strata. And this strata is similar groups. Okay, similar groups. So let's say gender could be a similar group, or race, or nationality, or religious beliefs. This could be education level. The different sampling groups we looked at with the stratified sampling represent different groups that might be of target interest. If we were to do a simple random sample, and we were looking at nationalities, for instance, the population, the whole student body at DBU, and we wanted all nationalities represented. Well, the students from Senegal represent a very, very small population on our campus, perhaps only 3 or 4 students. If we wanted to make sure we had every nationality represented, we'd have to stratify on nationality. So we'd have all Americans, Canadians, Mexicans, Japanese, Chinese, Korean, Senegalese, and so on and so forth. And we would split them into groups